Hi, Mr. Sapone here. This video is going to be on scientific notation. Recall that scientific notation is simply an abbreviation for very large and very small numbers used in science. It's a way to more conveniently express very large and very small quantities. And there are quite a few rules for scientific notation. The best way to learn how to do it, though, is pretty much to just jump right in and do some examples. And down here I have 4 steps that are going to help us. So we're going to take some of these numbers on the left and we're going to put them into scientific notation. And let's start with the number 200. And the first step I have down here asks, where is the decimal? Now this number doesn't have a decimal point, but you should know that there is an assumed decimal point right here at the end of the number. It's not written in, but it is assumed to be there. The second step asks you, where do I want it? And that's a curious question. It's like, what do you mean, where do I want it? It's fine where it is. But in scientific notation, there is a special rule. You always want there to only be one number to the left of the decimal point, and that number cannot be 0. So you want one non-zero number to the left of the decimal point. Right now we have 3 numbers to the left of the decimal point. So what I need to do is move this number over 1, 2 places to the left. And whenever you move to the left, we have a positive exponent. So we move 2 places to the left. So I'm going to write that as 2.00. The zeros aren't absolutely necessary, but just for illustrative purposes, I'm keeping them in, times 10 to the second power. And that is it. The next example, 4040. I asked the same question. Where is the decimal point? Well, the decimal is right here. It's assumed to be there. Where do I want it? And the rule is there can only be one non-zero number to the left of the decimal point. We have 4 numbers to the left of the decimal point. So I need to move this over 1, 2, 3 places to the left. And I'm going to write that as 4.04 times 10 to the third. I got rid of the last 0 because it's not needed. This 0 here is a placeholder. It is absolutely needed. So that is how you would write that number. And I'll do one more of the big numbers. Let's look at 24,000. Once again, the first step is, where is the decimal? The decimal is right here. Where do I want it? Well, I want it so there's only one number to the left of it, and that number cannot be a 0. So I have to move this over 1 place, 2 place, 3, 4 spots to the left. And I would write that as 2.4 times 10 to the 4th power. And that is how we put numbers into scientific notation. That rule is right here. When you're moving left, we have a positive exponent. This is for big numbers. Let's jump down here and do a few of these. See what we get when we have some small numbers. So if I have the number 0.001, we're going to follow the same steps in these rules that are up here. Where is the decimal? Well, in this case, it's not hidden. The decimal is right here. Where do I want it? Well, I want it so that there's only one number to the left of it. This is fine. There's only one number to the left of it, but that number cannot be a 0. So instead of moving left, I have to take this decimal and I have to move to the right now. 1, 2, 3 places to the right. And that means I'm going to have a negative exponent because I'm moving to the right. So I'm going to write this as 1 times 10 to the negative third. 1 times 10 to the negative third because I moved 3 places to the right. And let's jump down and do this one right here. 0.0000904. First step, where is the decimal? Obviously it's right here. It's not hidden. We don't have to assume or find it. Where do I want it? Well, there can only be one number to the left of the decimal, and it cannot be 0. So I'm going to have to move this over 1, 2, 3, 4, 5 places to the right. And that means there will be only one number to the left of it, the 9. And I'm going to write 9.04. I got to keep the 04 times 10 to the negative 5th. So that's how we do that. When we're going to the right, we have a negative exponent, and that's for small numbers. And when we have big numbers, we're moving the exponent left, or the decimal point to the left. One more. We'll do the bottom one just to make sure we are fluid with this. 0.003456. Look at that convenient number string. The decimal's right here. That's step 1. Where do I want it? So that there's only one number to the left of it that is not 0. So I'm going to want to put the decimal in between the 3 and the 4. Moving it over 1, 2, 3 places to the right. And I'm going to be stuck with, or end up with, 3.456 times 10 to the negative 3rd. And that's how we put numbers into scientific notation, big and small numbers. The entire basis of scientific notation is multiplying and dividing numbers by tens, which simply results in decimal points moving. This is Mr. Sapone. Hopefully that helps you.